All right, boys and girls, you know what time it is. It is Mr. Jordan math video time. So go ahead and get yourself out some paper, something to write with, and let's talk about section 4.2, perpendicular and angle bisectors. All right, the first piece we're going to talk about is a perpendicular bisector theorem. So two key words in there, perpendicular. Remember, that means that things form a right angle. And bisector specifically means cuts something exactly in half. And this says if a point is on the perpendicular bisector of a segment, then it is equidistant, or the same distance, from the endpoints of the segment. So we see here if PM, so that line PM, is perpendicular, that's what that little symbol right there means, is perpendicular, to segment AB, so perpendicular forms that right angle right there, and MA, so that segment on the left, is equal to MB, so that means it bisected it, it cut it in half, then lines drawn from any point on PM there to the endpoints, one to point A and one to point B, are going to be the same distance or the same length or congruent as well. Okay? All right, so that's the first part there. Then we get this, the converse, or kind of the opposite of that perpendicular bisector theorem. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So now we're starting with what we ended with on the first one. We're starting with the fact that this point P is the exact same distance from both A and B. Well, if that's the case, then that point P lies on this line that is both perpendicular to AB and cuts segment AB exactly in half, or it bisects that segment there. So we get both of those pieces there. We can start with one, get the other. We can start that something is on the perpendicular bisector, then it's the same distance from both the endpoints. Or we can start with something being the same distance from both of the endpoints and conclude that it is on the perpendicular bisector. So, all right. Now we're going to look at some questions here that use this concept. So in this case, it wants to know what is the length of AB. So that is this length right here. All right. Well, we're getting some things here. We're told that AD and DC are congruent. They both have the one little hash mark on it there. We're told that BD and AC are perpendicular because I have that little right angle symbol right in there, all right? Well, if BD is at a right angle and it cuts AC in half, then B must lie on the perpendicular bisector of AC. If it does, then B is the same distance from A as it is from C. So AB and BC are equal, hence 4x equals 6x minus 10. We can solve this. It's just a two-step equation. Subtract 6x from both sides. Negative 2x equals negative 10. Divide by negative 2, and we get x equals 5. Now, that's not the length of AB. Does still want to know the length, so we need to plug that 5 in. 4 times 5 gives us AB has a length of 20. Okay, so that's using our perpendicular bisector theorem to answer that question there. So second one here, go ahead and pause, answer this one, and then come back and check your answer. All right, you can see the equation we should have set up for this one, and we get that QR has a length of 8. If you didn't get that, go back and check your work, and if you still can't figure it out, make sure you ask your teacher what you did wrong on that one there. All right, so now we have a little bit of an application problem for this one here. So a park director, if you think of something like Kings Island or Coney Island here, they want to build a t-shirt stand that is equidistant or the same distance from both the rollin' coaster down here and the spaceship chute right over here. So what are the possible locations for this stand? Okay, well, we just learned that if I draw a line here that goes from the roller coaster to the spaceship chute, and then if I draw a line, and this isn't going to be exact here, But if I draw a line through this that is perpendicular and bisects the line between the rolling coaster and the spaceship chute, then any point along this line, whether it be there, or it could be there, or it could be here, or down here, okay, wherever it might be, any point along that line is going to be the same distance from both the rolling coaster and the spaceship chute. Okay, now we're going to talk about the angle bisector theorem. Okay, and again, like the last one, this is going to be relatively intuitive for us here. So again, we've talked about bisector here. Now we're talking about an angle as opposed to a segment. And this one states, if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle, or the same distance from the sides of the angle. So if QS bisects, so QS, so that line there, bisects or cuts in half PQR, that angle right there, SP is perpendicular to QP, so SP perpendicular to QP, and SR is perpendicular to QR, then those lengths, SP and SR, find this length here and this length here, are going to be equal. All right, and then we see here, now we have the converse of that angle bisector theorem. So again, just like the first theorem we were looking at there, again, we kind of get these in both directions. This one then, if a point in the interior of an angle, so it has to be inside that angle, in this case inside PQR, if it is the same distance, equidistant, from the sides of an angle, then the point is on the angle bisector there. So SP is perpendicular to QP, so SP and QP are perpendicular, and SR and QR, they are perpendicular. And we see that SP and SR are equal or congruent there. Then because of that, S must lie on this angle bisector that we see cuts this angle exactly in half there, okay? All right, and then lastly, now we are going to use this angle bisector theorem again to solve some problems here. So it wants to know what is the length of RM. Well, that is this length right here. Again, RM and RP are perpendicular to the sides of the angles, and we see that RN is the bisector of MNP. See, we have these little partial circles down here, so that means it is cutting that angle exactly in half. That means that RM, or 7x, is equal to RP, or 2x plus 25. And again, a little two-step equation for us to solve here. We subtract 2x, we get 5x equals 25. We divide by 5, we get x equals 5. Again, we want to know the length of RM, so we plug that 5 in to our 7x, and we get the length of RM is equal to 35. All right, again on this second one here, go ahead and pause, work through it on your own, and then come back and check your answer. All right, so again, similar to the last one, we could set those two parts equal to each other, solve for x, and then substitute x back into our expression, and we find that the length of FB is 21. Again, if you have any questions, make sure that you ask your teacher. You can also obviously do question help on Math Excel, and that will help you solve problems. And if you Google this topic, I'm sure you will find numerous other videos that will discuss it as well. Hope y'all have a wonderful day.